And so if you go back to the early 2000s, when people really started talking about nanotechnology outside the academic realm, people started talking about carbon materials are good conductors. So there's graphite, and then carbon nanotube and graphene. And it's great, it's got high strength, high electrical conductivity, high thermal conductivity, and low density. But what was coming up, what you could get in your hands in 2000 was something that looks like what's in this vial. A totally structureless material, which at the nanoscale had really good properties, but when you made something that was even a centimeter big, had no integrity, just a little bit better than carbon black. And then what happens in the 2000 through 2010, we started getting from these type of materials to this type of material, so we could shape them. It's the same difference between having, let's say, the wool on a sheep and actually having a really nice yarn of wool that you can now use to make clothing. As time went, properties got better and better, and now, right now, this is kind of where these materials are, and this was done by basically changing structure. This is disorder fibers from the early 2000s, and that's what we can make right now. Now, this is like about a sixth of what copper can do, and copper is essentially the best conductor that's used commercially. Now, the area where we are right now is an area where we start looking for actual applications. For example, we can make cables. And so these are coaxial cables that are made with carbon nanotubes as conductors, and they're much, much lighter than the carbon nanotube, the cables made out of copper. And that's the kind of application areas that we can look at where cost per kilogram is high and volumes are relatively low. But then, as you see, this is something where we're already seeing that we can move down this cost volume line. And for example, there's subsea applications where umbilicals can cost in the $1 million per kilometer. And of course, not the whole umbilical is made out of conductors, but it is an application where it's still high value. And already we got the attention of car manufacturers. And one of the reasons why they're paying so much attention is right now there's only about 30 kilograms of cables in a car, but as the cars are getting more and more into instrumentation, especially as you go towards autonomous and self-driving vehicle, that amount of cables is becoming bigger and bigger. Nanotubes are ideal building blocks for this new generation of materials. And they're already ready for aerospace and subsea, and they look really like the ideal building blocks for wearable applications.